Have you ever wondered if we can create games utilizing React Native? Well, wonder no more because in this tutorial, we're going to learn how to create a classic snake game utilizing React Native and TypeScript. If that's something that you are interested in, make sure that you subscribe and like this video. Welcome back to Code with Beto, guys. In this video, we're going to learn how to create a snake game utilizing React Native and TypeScript. So let's see a demo of what we're going to be building today. And this is already functional. So I'm going to start by reloading this game. And this is a pretty simple functionality. We just have this little snake that is going around the screen. And whenever we swipe up or we swipe left, down, and right, we are moving this snake. And every time we eat an apple, we are increasing the size of the snake, right? So it's pretty simple. And whenever we hit a wall, we lose, of course. Here we have a point. We also can reload the game and pause the game and continue the game, play the game, right? Right. So this is basically what we're going to be doing. As always, guys, if you want to just jump into the code, you can go to codewithbeto.dev/projects, and you're going to find all the projects that I have in this channel. If you are interested, here we have the snake. We can scroll down. We can check the dependencies that we're going to be using, and you can access these links of GitHub. And if you want to just download the project, you can just download it as a zip file, right? So now that we know that, of course, I have to tell you guys that if you are interested in mastering React Native, I have this React Native course in Spanish. So be careful. I'm working on translating it to English, but at the moment it's in Spanish. So if you want to support this channel, if you want to become a master in React Native, make sure that you check my React Native course. Now that that is out of the way, I'm going to close this and let's start by building this amazing project. Now, I almost forgot to tell you guys that this project is going to work as well on Android. You can imagine because we are using React Native. But yeah, basically we have the same functionality on Android. And I was thinking that you can create an online game in which you can have two players competing to see who got more apples, right? It will be super nice. You can do that as a homework. But yeah, I'm going to remove this device for now. I just wanted to show that it works on Android. Now, for now, guys, I want to make sure that we understand what are we gonna do, okay? Because there's many ways we can tackle this problem. We can create this game in a different manner. So let's see what we're going to be doing, right? So here we have our device, and let's say that this is going to be our snake. This is going to be super easy because it's pretty simple. It's just a view. We can use as well an image to represent the snake. But yeah, we can do that in React Native using a view, right? So pretty simple so far. Now, how we can move this snake? Because we're using React Native, we can use gesture handlers to detect when the user is swiping his finger up, down, right, or left. And based on those gesture events, we can move the snake, right? Now, how we can move this snake? Well, let's say that this height of the device is going to be our y-axis, and this up here is going to be our x-axis. So as we can see now, this snake or head of the snake is going to have a position on the x and y axis. For example, at this point, it could be something like 2 and 3, right? Now, whenever we want to move the snake, what we can do is just simply grab the snake, make a copy of the snake, and increase the x plus 1, right? So basically, we grab x, we increase 1, and j and y, we just leave it like that. So this is going to create us another snake in this position. And now what we need to do is just simply delete 1 from the rest of the snake, right? So I'm going to delete this one, and we successfully moved our snake. Now, let's imagine that we have already eaten some apples and our snake is looking like this. So this is our head. And now the users want to swipe down. So we want to move down. So we grab this head, make a copy, and we are going to grab x and y, and we are going to add 1 to y. So now the next copy is going to be down here. And what we need to do now is grab the rest of the snake and just remove the first element because we moved the snake. But what if we ate a apple? But we can simply just create a copy into the next position and don't remove anything. If we eat an apple, right? So let's say that we are eating apples, so we are increasing the size by 1 of the snake. If we don't eat anything, we just remove the last item, and that's how we successfully move this snake. Of course, there's something else that we need to keep in mind. Of course, for example, let's say that this X is going to be an apple. Every time we eat an apple, of course, this snake is going to have as well a position on X and Y. And whenever we eat this snake, we want to increase the size of the snake and delete this and get a random position between these bounds of the game, right? Between the screen. So for example, let's say that we eat it and now it's going to appear down here. We can do that as well, just getting random values, having in mind that this is going to be our 0 position, and at most we are going to have, let's say, 30 on the x-axis, and let's say that we have 80 pixels of height on the y-axis. So this is going to help us as well to know whenever the user gets out of the bounds. So for example, if I just move my snake this way and we hit this wall, we're going to check that by checking if the position X is greater than 30, it means that we lose. As well, if the position X is less than 0, it means that we move out of this position, so we lose, right? We are going to have the same validations for Y. If Y is less than 0, we lose. If Y is greater than, and in this case, 80, we lose. That's basically how this is going to work. And of course, we want to be generating this random food between these bounds, right? So now that we have this basic understanding of what we're going to be doing and how we are going to approach this problem, let's start by creating our React Native application. So here I have my terminal and it's in my desktop. As you can see, I'm going to start by creating this project using Expo, right? Because it's the fastest way we can do this. You can use the CLI, no worries. It's going to be the same functionality. So to create an Expo application, we need to run the command create Expo app. And because we want to be using TypeScript, I'm going to add the template flag. So we're going to be asked if we want to use TypeScript. And of course, we want to use TypeScript in this case. You can choose navigation with TypeScript or just blank TypeScript. I'm going to choose blank TypeScript. And for the name of my project, I'm just going to call it Snake for now, right? Hit enter, and now let's wait until the project is ready, right? Notice that we are installing these dependencies using npm, and our project is ready. So now we can access this snake folder in our desktop, and now we can start by adding the dependency, the only dependency that we're going to need for this tutorial. It's going to be React Native gesture handler, and because I'm using Expo, I can just run Expo install React Native gesture handler. If you are using the CLI, make sure that you check the documentation to see how you can install it. So let's hit enter. And once this is done, that's pretty much all we need to do. We can start working on this application. So I'm going to open this project on Visual Studio Code. All right, here we have our project. And the first thing that I want to do is just run the command npx expo start to start our development server. Now we can just go to this iPhone and reload by pressing Ctrl Command Z, and this is going to be reloading. All right, so our application is working. I'm going to close my terminal for now. We're not going to be using it. And let's go to our app.js, app.tsx, because we are using TypeScript. Here we have pretty much all we have in this application at the moment, because as you know, in this channel, we always create applications that are reliable, scalable, and maintainable. So we're going to start by creating a structure of this folder by creating a folder called source. Inside this folder, we can have another folder in which we are going to put our components. Inside source, we are going to have a styles folder. This is optional. Of course, you can use, you can put your styles as you want, but this is like an scalable manner to do it, because we're going to have some colors through our application, and we need to reference these colors. And sometimes if you want to change one color, instead of going on each component trying to change the same color, we can just go to the styles and change one color, and our application is going to change, right? Everything. So we're going to have styles, and then because we are using TypeScript, I'm going to create another folder in which I'm going to put my types. Then finally, we're going to be using another folder to store our utility functions. So I'm going to call it utils, because when we are creating this kind of applications, we're going to be using many utility functions, like for example, to detect if the snake head is at the same position of the apple foot, right? So if they are at the same position, we can increase the points and increase the size of the snake. So we need a function to do that. And we can abstract, make our code more modular by abstracting these functions in a utility folder. Perfect. Now let's start by creating our first component. Inside my components, I'm going to create a game.tsx. And just for now, I'm going to close my Explorer, and I'm going to start by importing all as React from React. So it's going to look something like this. And then we can export the full function, this game like this, right? Now, guys, because we are using TypeScript, we can define the return type of this component, and it's going to be a JSX element. Now it's red because we are not returning any JSX element at the moment. So I'm going to put return, and now it's red down here because we need to provide a JSX element. In this case, I'm just going to put a safe area view from React Native. All right, so I'm going to start by adding some style to this view. So let's go back to our Explorer, and inside styles, I'm going to create a new file called colors, and it's going to be lowercase colors.ts. And this colors.tx is going to be simply the colors that we are going to be using across this application, right? So now I'm exporting this object of colors. Now I can close it and use these colors inside my game. So I'm going to create some styles down here, and by saying style sheet from React Native dot create. This is going to take an object of classes. My first class is going to be called container. So container is going to look something like this. I'm going to close this Explorer for now. And let's say that we want to have a background color of my colors. I'm going to import these colors from my styles color, you can see here, and dot primary. This is the primary color. So if I hit save now, and now we can go to our app.tsx file and basically delete everything that we have in here and just try to keep this component as clean as possible because this component is the entry point of our application. So I'm just going to say const app, and this app is going to be my component equal to, and I'm going to create an arrow function because I think it's more cleaner. And for now, let's just return a game, right? So if I import my game from my components, this is going to look something like this. Now I'm going to reload my application, and we are getting this error, and that's because we are not exporting these components. So I'm gonna say export default app. All right, hit save, and now we can try to reload this application again. Okay, so now it looks like it's working. Let's go back to our game.tsx, and we can add this style inside this view. So I'm gonna say styles.container, hit save, and as you can see, we have the primary color up here. Of course, we are not taking any height. We can do this by adding flex of 1. This is going to grab all the space available on screen, and it's gonna fill it, right? So we have now our background color. It's looking good. Now, one important thing, guys, to keep in mind, when we are using React Native gesture handler in our application, we need to add this import up here, just like that. It's like a requirement in order to have this library working correctly in our application. Now, another important thing is that we need to wrap this game or this application inside a gesture handler root view. It's going to look something like this, and I'm going to put my game inside this gesture handler root view, and I'm going to delete that space. And that's pretty much all we need to do. But of course, as you can see here, we are again just taking this space. So I'm going to add a style, and in this style is going to be simply an inline style of flex1 in order to take the full height of the screen. So you gotta make sure that you wrap your component inside the gesture handler root view in order for this to work on Android, right? So now let's hit save and let's go back to our game. And now let's try to create a function to detect when the user is swiping their finger. So inside my game, we are going to have this function, and this function is going to be called handle gesture, right? This is going to be an arrow function, and this arrow function it's basically going to receive an event. So I'm going to say event, and for now, I'm going to say any. Now, inside my return, I'm going to open these parentheses, and we're going to need to import a pan gesture handler from React Native gesture handler. Now, inside this, we can add this, this safe area view. And of course, we need to delete this semicolon. Hit save and try to reload this. Okay, so now it's working. So once we have this pan gesture handler, we can access the gesture events by saying on gesture event, and then we can call our function handle gesture, right? So this is going to generate an event that we are receiving here. And for now, let's say that we want to put that event on console just to see what we are getting, right? So I'm gonna say console log event, open my terminal and all the way here. Now let's drag our finger, and as you can see, every time we drag our finger in the screen, we are getting a bunch of things down here. Now let's add something called native event. Hit save and clear our terminal and drag again. And now it's starting, all this data is starting to look cleaner. We have something called absolute X, and we have something called absolute Y. We also have translation Y and translation X. So those values are the ones that we're going to be using for this tutorial, because those values are going to tell us the direction which the user is moving their finger, right? So let's put this down here. Let's go back to the console log. And now, instead of putting this console log, let's create two variables by destructuring from the event the translation on the x-axis and translation on the y-axis. And let me delete these parentheses. And now let's put that on console. Console log translate x and translate y. Hit save. Let's open our terminal again and drag our finger. As you can see, if I drag my finger down, I'm getting on the y-axis these values that are positive. Now, if I drag my finger up, we are getting y values that are negative. If I swap my finger through the left, we are getting x values negative. And if I swipe to the right, these x values are going to be positive. Now, it's worth noticing that when we swap our finger to the right, of course, we can go right and then like right up or right down. So we are not going to be in a straight line because we are humans, right? So we are getting some values in here. Now, how we can use this data that we know already we are getting here to move our snake? Well, we can simply delete this console log and get, first of all, the value between these two that is bigger. So that is going to tell us if we are moving on the x-axis or y-axis. So by saying, also you gotta keep in mind as well that these values can be negative. So we're going to grab the absolute value of translation x, and we're going to check if that is greater than the math dot absolute value of translation y, right? So this is going to tell us basically if this is greater than y, it means that we are moving on the x-axis. So now we can see, we just need to detect if we are moving to the right or we are moving to the left, because we know that we are in the x-axis. If translation x is greater than 0, it means that we are moving to the right. So I'm going to put a comment here, moving right. Otherwise, it means that we are moving left. So I'm going to say moving left. And otherwise, in the case that x is less than y, it means that we are moving on the y-axis, up or down. So we need to check if we are moving up or down. So I'm going to say if translation y is greater than 0, it means that we're moving down. So I'm going to say down. Otherwise, it means that we are moving up. So I'm going to say up. Perfect. So now that we have this, let's start by creating some types that we're going to be using in here. So I'm going to go to my types folder and I'm going to create a new file called types.ts. Of course, you can name it as you want. And let's start by creating a type that we're using already. This is the native event type, and we are getting the X and Y axis, and these are numbers, right? So let's hit save and now use this native event inside this function instead of having this any, right? Now I need to quick fix this and add an import so we don't get that error. Perfect. Now let's create another type that we're going to be using, and this type is going to be an interface as well, and it's going to be a coordinate. So I'm going to call this type coordinate. We are going to have basically two values in each coordinate. The first one is going to be an X, and the other one is going to be a Y. Both are going to be numbers. We already know that. And now we can use this coordinate type. As well, we know that we can move up, down, right, and left. So let's create a type that is going to keep these values. And this is the perfect case in which we can use an enum. If you are not familiar with enums, basically are values that are constant. In this case, up, down, right, left. These values are constant and they are never going to change. But the user can only use one of these values every time. So we can just go to the right, to the left, up, or down. We can use enum of as follows. So we can say direction, and we can move to the right, we can move to the left. Basically, we are defining, well, I'm gonna say right, up, left, and down. Basically, we are defining the values that we can take in this enum, right? So now that we have these values, let's go back to our game, and all the way up here, I'm going to start by declaring some variables that are going to help us to manage the game in an easy manner. So let's paste this for now. We are going to need an initial position for the snake. So this is going to be a constant variable, and this is going to be just one X and Y position. And then we're going to need a position, initial position for the food. It's going to be an X and Y. Then we're going to need the game bounds. This is really important, and we saw this in the conceptual overview of this video. And basically, we are defining that the minimum X is going to be 0, the minimum Y is going to be 0, the maximum X is going to be 35, and maximum Y is going to be 63. If the snake goes out of these bounds, it means that we lose the game. Perfect? Okay, so I already know these values because I've been testing this a little bit, and it's just going to be 35 in the case of the iPhone. Of course, this is maybe not the best way to do it, but you can improve it in your house if you want, right? So now move interval. We're going to be moving the snake every 50 milliseconds. And to update the movement of the snake, we're going to be using a interval of JavaScript, and we're going to see that in a couple minutes. And as well, we're going to need a score increment. So I want to increment my score by 10 points every time I eat an apple. Perfect. Now that we have these constant values, it's going to be easy for us just whenever we want to change some value, just come on the top of this file and change it here. And we don't have to even look at the code because we have all this abstraction in here. Perfect. So now inside this game, let's start by creating some variables using states from React. The first one is going to be my direction. So I'm going to say const direction and set direction equal to use state from React. And the first value of this is going to be a direction to the right because we want to be moving to the right. So I'm going to say direction, importing my type from my types, and dot right, right? So it's looking pretty good. We can also add the type of this state here. We can say that this is going to be type direction, and the first direction or the default value of this direction is going to be to the right. Good. Now that we have that, we can add another variable called snake. We're gonna need a snake. And one important thing that I forgot to mention, up here, we have an array of basically coordinates. We have an array in the snake because we can have many snakes, right? We're going to start with one head, but every time we eat an apple, we're going to be creating more and more. So that's why we need to keep track of the position of each part of the snake. That's why we are creating an array of positions, right? Now, let's say down here, set snake. And for now, we're going to be saying that this is going to be use state as well. And the initial value for this snake is going to be snake initial position. Now let's add the corresponding types. This is going to be type coordinate. So it's importing from our types, and let's close it. Now we're getting an error, and that's pretty normal because this is an array and we are saying that this is type coordinate. So we can simply add some brackets here to say that this is going to be an array of coordinates. Cool. Now that we have that, we can create another, basically the same thing. I'm going to duplicate this, and this is going to be our food, and set food. Cool. Now, food is not going to be an array. It's just going to be one position, and the initial position is going to be equal to the food initial position that we have up here. Nice. This is looking pretty good. Now, we also need to know whenever we lose the game, and we also need another variable to keep track of how many points the user had. So I'm going to create these two variables using React.useState. As you can see, this is going to be Boolean values, and the initial value is going to be false. Now let's hit save, and that's all we need for now. Now we can go back to the handle gesture function, and whenever we are moving to the right, we can simply say that set direction equal to direction.right. This is looking pretty nice, right? It's super easy. Now that we have this enum, we can say that we're moving to the left in this case, and I'm going to copy, paste down here, and in this case, we're gonna be moving down, and finally, I'm going to copy this for the last time, paste it here, we can go up. Cool. Now we have this direction. Every time we move the finger, we know where are we going. Okay, so I'm going to close this handle gesture for now. And now let's create our snake so we can start moving the snake, right? Let's go to the components, create another file called snake.tsx. And this snake is going to be a pretty cool component because we know that we are receiving an array of positions, right? So I'm going to say just export default function, and I'm going to export my snake. And my snake is going to take a snake as a parameter. And this function is going to return a JSX element, so we can define it here. And now we need to declare some types for this snake. So I'm going to create an interface that is going to be called snake props. We know that we're going to receive an array of coordinates. So I'm going to say snake is going to be of type coordinate, like this. Now I need to import this coordinate type, add the import, and now we can put that this snake is going to be of type snake props. Perfect. Now this is red. We already know that because we need to return a JSX file. And for now, I'm going to put a fragment from React. For those who don't know what a fragment is, it's basically an empty tag. But I believe that fragment looks pretty much, looks better than this empty ugly tag. Cool. Perfect. So we have a fragment, and inside this fragment, we can start by iterating on each point of the snake. So I'm going to say snake.map, and we are going to start iterating for each segment. The map function is going to return as a second parameter, and you can see here an index. So I'm going to grab that index because I'm going to need a key to tell React that which element is which, or what part of the snake is what part. You can see here down here, this is going to be a tab number, and I need to create my function. And this segment, each part of the snake is going to be of type coordinate. So I'm going to say type coordinate. inside this function, we can return a JSX element, which in this case is just going to be a view. So I'm going to import this view from React Quick Fix from React Native. Cool. Perfect. So we have a segment which is going to be X position and Y position of each part of the snake. And we are iterating over each part of the snake. Now we need to pass the key here, and the key is going to be the index that we are grabbing from the map function. And finally, we're going to add some style for this snake. But before we do that, inside this function that we're creating here, I'm going to grab the position. So I'm going to say segment style, and we are going to be moving the snake on the X and Y position, right? Axis. So for that, I'm going to create some styles, and by importing a style sheet from React Native, I'm going to say create, and we're going to create a class for the snake. I'm going to give it a width of 15, and let me scroll a little bit, height of 15, and then we can say background color of our colors. I'm going to import my colors from my styles, and my color is going to be primary. Now, something very important here is that the position is going to be absolute. This is going to help us to move on top, down, right, and left. Now, I want this snake to have a border radius. So I'm gonna say border radius of 7. Now we can go down here, to the line 17 and add this style. So my style is going to come from my styles.snake. Cool. Now we need to be updating this style each time or for each one of these segments. So I'm going to say left. Left is going to be equal to segment.x multiplied by 10. And this 10 is going to be, you can change this 10 to adjust whatever you want. Basically, it's the size of each segment that we're going to be moving the snake. Then top, we're going to move left. And this left position, it's like adding here a left because the position is absolute. We are moving to the X to the right or to the left. This number can be positive or negative. And then top is going to allow us to move negative top and positive top, right? So segment dot y multiplied by 10 as well. Perfect. Now we can add this style here, so we can update. I'm gonna say segment style, and because we have two styles at this point, we need to add an array of styles. Cool. Now this is looking pretty cool. Let's go to the game, and let's put inside this save area view another view. And this view is going to be from React Native, and inside this view we can create our snake. So I'm going to import my snake, and this snake is waiting for a snake as a prop. So let's pass our snake, and it's going to look something like this. Cool. Now we cannot see the snake because the snake is of the same color of this background. That's why we need this view. So let's add a style for this view from my styles, and this is going to be called boundaries. And I'm going to copy this. Let's go down here and create this style boundaries. Now, these boundaries, it's going to have the following style. Basically, we're grabbing all the space available with this flex one. Then we're giving the background color primary. Then we're giving a border color primary, border width of 12. And this border width is going to be basically this margin that we have here. And now we can see the snake, it's in here, but it's not moving at the moment. So once that we have these boundaries, we can start moving the snake. So how we can move the snake, we already see that. We already talked about a little bit how we can do that movement. We are going to create a function that is going to help us to move the snake. And this function is going to be called move snake. It's going to be an arrow function. And basically, we're going to be moving the snake, like I said, every 50 milliseconds. So the first thing that we want to do is just grab the snake head. Remember that we needed the snake head. So the snake head is going to be basically in the array of the snake at the position 0. Now, once that we have the head, we are going to move it to the next position. So we cannot just change, like saying snake head dot x and y equal to 10 because we're using React. We need to create a copy of this head. So to create a copy, I'm going to call this constant new head like this, and I'm going to destructure this snake head like this. So here basically we're creating a copy of this snake head, and now this new head we can just update its values as we want, and then we can replace the state of the snake by passing the new head. Now I'm going to start by writing some comments of things that we need to do later. In this case, we are going to need to check whenever the game is over, and the move snake function is going to be the perfect place to check that. We are going to create this function later. Now, like I said, we can now mutate this copy of the head of the snake. Now we can simply have a switch statement here and check in the direction in this switch case. Now, the first case, it's going to be if the direction is equal to up. In this case, what we want to do is just simply say new head at position Y, we are going to decrease 1. So minus equal 1, and then break. And this is what we're going to be doing for each case. So I'm just going to paste this, this that I have already here. If we are going down, we are going to access the y-axis and increase by 1. Then if we are going left, we subtract 1. If we are going right, we increase 1 on the x-axis. Cool. Otherwise, the default value, we're just gonna break. We don't have any other case. Now down here, we can set the state of the snake with the new head. So we can simply say set snake equal to new head plus whatever we had on the snake already, because it could be that we had already eaten some stuff, right? Now let's leave this like this. Of course, this is a bug. We're gonna check it later, but let's leave it like that for now. And now let's come all the way here on top, and let's create a use effect in order to be updating this move this snake every 50 milliseconds. We're gonna need a use effect. Now this use effect is going to take two parameters. The first one is going to be this function, and the second one is going to be an array of dependencies. So inside this array of dependencies, I'm going to add the variables that I want to check every time they change to run this functionality that we have in this function. So inside this function, we can simply check and move the snake. So we have already that function. But one thing that is cool to do is just like move the snake if the game is not over, right? Now, every 50 milliseconds, so we are going to create an interval. So I'm gonna say interval ID. It's going to be equal to set interval. And this set interval is going to take two parameters as well. The first one is going to be a callback function, and then the number of milliseconds that we want to wait before we run this code again. Now, if you remember, we have this move interval up here, so I'm going to paste it in here. This is my interval of 50 milliseconds. Now, inside this interval, what we want to do, we want to move the snake. But another cool thing that we can do here is that just move the snake if the game is not paused, like this. Cool, it's looking pretty cool, right? Now, in the case of this component is unmounted, we want to remove this interval to prevent memory leaks. So the use effect hook provides us this return cleaner function in which we can run this code whenever this component is unmounted. So I'm going to write clear interval, and which interval we want to clear, we can pass the ID of the interval that we want to clear. In this case, it's this one. Cool. So now we are not going to have memory leaks, and we can add in this array of dependencies when we want to run this use effect. So we want to run this use effect whenever the snake changes We want to run this use effect whenever the game is over to check if the game is over and whenever the game is paused. Cool. So now let's hit save. And as you can see, we start moving our snake, but something really important. It seems like we are eating a bunch of apples because our snake is growing and growing and growing. Now, how we can fix this bug? Well, we can go back to this snake, and if you remember, like I said in the conceptual overview, we need to remove the last position of the head, right? So we can say slice in this snake or the rest of the snake that we are appending to the new snake position. And then we can have negative numbers here to have offsets. And as you can see now, every frame, we are removing one from the tail and it's working. Now, if I reload this, we can see that our snake is moving and we are removing that last element with every time we move. Now, we want to grow this snake eventually. So we can have a check here, like it's going to say if it's food, we want to grow the snake. So I'm gonna say grow snake. Otherwise, we just want to keep moving the snake. Cool. Now, let's hit save and let's start by adding this game over function. This game over function is going to basically check if the current position of the snake is greater than the bounds. We are going to lose the game. So let's create this utility function. This is going to be a utility function and it's going to be called check game over.ts. Cool. Now this function is going to receive the boundaries and the coordinate. So the coordinate is going to be of type coordinate. And now we can export const check game over. And this is going to be an arrow function that is going to return basically a Boolean. So now we need to return a Boolean, but we're going to take as well the snake head, which is going to be of type coordinate and as well the boundaries of the game. And the boundaries are going to be of type boundaries. Of course, we don't have this type, I think. So I'm going to say just any for now. Now, this is going to return if, well, in this function, we need to check if the position of the snake is greater than the bounds. So we can say snakehead.x if the snakehead.x is less than 0, basically, or we can say boundaries.xmin. It means that we lose. Or I can duplicate this in the position x, it's greater than x max, it means that we lose. If position y it's greater than y max, we lose. And if position y is less than, less than 0 basically, so y min, we lose. And that's all we need to check in this function. Now I need to remove these last two lines, and after some formatting, it's going to look something like this. Now let's go back to the game, and instead of having this comment here, we can say if check game over, and we're going to pass the snake head and as well the boundaries. So I'm gonna say boundaries. So I'm gonna say game bounds, and if this is true, it means we lose. So we can say set game over is game over equal to true in this case. Now, one important thing here is that this is going to keep running whenever we set this game over equal to true, because React is going to try to update the state after it finished running this. So we are going to have here a return to prevent keep going. And then we can update this variable right away by accessing the previous state and put the previous state to be whatever the previous state was, but the negation, right? Now, this is going to run right away, and then we're going to break from this, and this is going to activate this is game over dependency on the use effect. Then we're going to check if is get, in this case, it's going to be true game over. So we are not going to enter in this if statement, which means that we are not going to be moving the snake. Now let's try to see if this is working. Let's reload and let's hit the wall. As you can see, the snake, it's there, stops because we lose, and stops if we go to the left, stops if we go to the top, and if we go all the way down, it should stop. Okay, it's stopping. As you can see here, it seems that my y max it's a little short. If I say 70, let's reload and let's try to go down. Um, Perfect. So this is what I was saying, you guys. We can now move this variable to be 71, for example, and it's going to be working fine, I think. Cool. So every time we need to change this variable, we can come up here and do it. Now let's start by creating the food. So I'm going to create another component, and this component is going to be called food.tsx. And because I don't want to do this, this tutorial super large, I'm just going to copy this component that I already have here. I had this idea of getting a random fruit every time, but I couldn't implement it. So if you want to do that, you can try it. Basically, this was my idea, to grab one of these fruits every time. But now, for now, we are just going to limit ourselves to have this apple. This food, guys, it's going to be very simple. We are just grabbing the coordinate as a property, and then we are moving the y and left multiplied by the segment we want to move, in this case 10, and then we pass the style food. So this is very similar, very similar to what we have in our snake, but in this case we just have one element. So we just grab this and put it on the screen. That's all we need. Now let's go back to the game, and inside this view, let's put our food. This food is going to take the x position of the food, so we can say food.x, and the y position of the food, so we can say food.y. Cool. Now, if I hit save now, you can see that the apple is in the first position. Now, if I reload the game and try to eat this apple, nothing is going to happen because we're not handling anything when we eat the snake, the food, sorry. Now, let's create a helper function that is going to help us to check if we eat the food. So I'm going to say check eats food.ts, and this function is going to be pretty simple. I'm just going to paste this coordinate parameter. The check food is going to receive three parameters. The first one is going to be the head of the snake. The second one is going to be the food, which basically is the position of the head, the position of the food, and the area. What is the area? Well, the coordinates are very precise. So it could be that if we pass really close to the apple, it's not going to be the same coordinate. So we need an area uh, to basically, if we pass close to the apple, close enough, is going to count like we ate the apple, right? So that's why we need this area. Now, we need to calculate the distance between the food and the snake in the x-axis. So we grab the absolute difference between x head and x food. We are going to do the same on the y-axis. So we grab the absolute difference between y and y of food. And then we return true if the distance between the food and the snake and the xy and the x-axis is less than the area. So if the area is 2, for example, and the x position of head is 0, and our current position is x2, it means that the area is almost, so it means that we grab the snake, the apple, and we are going to check the same thing on the y-axis. Cool. So now, if this is true, it means that we ate an apple, right? So let's hit save now. Let's go back to the game. And now we can, instead of having these comments, check if it's food. We are going to pass the head. So I'm going to say new head in this case, and the food. So I'm going to pass the food. Cool. Now the area that I want to check in this case is going to be true. Now, what do we want to do whenever we eat a food? So we can copy this snake, and we want to increase the size of the snake. So if I delete this slice, we're going to have the same functionality in which the snake was growing and growing, but this is going to pass just once because we're going to move the foot out of the way. Now, here we need to get another position for the foot, and then we want to set the score. So we need to create a variable to hold this score. I'm gonna say, basically we can duplicate this and call this score and set score. The score is going to be use state, and this is going to be a number, and the first score is going to be 0. Cool. Now, whenever we eat something, we can set the score to be equal to whatever we had on the score plus the score increment, which is 10. Perfect. Now, we need to create another helper function to see if we, to get another position for the food, right? So let's go back to the util functions and create this function called random food position.tx. This is going to be a pretty simple function. Basically, we're going to grab a coordinate type because we're going to have, we're going to return a coordinate, and we're going to grab the max x and the max y. Because we're going to generate an x and y position, we need to know what are the bounds, right? So the bounds, we're going to pass these bounds as parameters, and then we can return a random number on x and a random number on y multiplied by max y and max x, right? So basically, this number is going to be between 0 and the max on y, and between 0 and the max on x. Cool. Now we return this coordinate and hit save. Let's go back to the game. And instead of having this comment here, we can say set foot to be a random foot position. Now we need to pass the bounds. So I'm going to say bounds, game bounds. The max on x is going to be x max, and game bounds and max on y. So y max. Cool. Now, if I hit save now, and let's try to reload this game, try to eat the food. As you can see, it's moving to another position, but we have a problem here. The problem is that we are hitting this line of code, so we simply can add an else statement and move this on here. Now, in the case that we are eating the food, we are going to grow the snake. And in the case that we are not eating a food, we are just going to move the snake. Now, let's hit save, reload the game. Now, let's try to reload the game. And every time we eat an apple, as you can see, we are growing twice. Why this is happening? And of course, if you pay attention, the apple is moving twice. So we are getting the position twice. And this is just simply because we are setting the food after the snake. So if we set first the food, we are going to have this functionality. It's working. Okay, and now if we try to do this, we are going to see that we are just growing by 1. Cool. Now, I think this is most of the functionality that we wanted to add in this function. Now we can concentrate our efforts in trying to generate controls for this tutorial, right? So we're going to create our header component. So let's go to our components and create a header to have the score, to have the buttons to reload the game. So this header is going to be a TSX file. Now guys, because I don't want to make this video super large, I'm just going to paste this component that I already have here. Basically, I'm defining the props that we are getting in this component, which is going to be the function to reload the game, the function to pause the game, the children, and is paused. Cool. Now, all these functions, we are using them here. We are setting the type so we don't get an error. This component is going to return a JSX element, and basically it's going to be a view. Simple enough. We are going to have 2 buttons. The first one is going to be a touchable opacity. Whenever we press this button, we reload the game. We are using icons from Expo Icons, Ion Icons, and Font Awesome Icons to play the circle and reload circle. Down here, we are putting the children at the end. And basically, these are 2 icons. That's all we need. and we're adding some style to this container. The flex 0.05 basically is the space that we're grabbing from this container from height, and you're gonna see how this works in a second. So now let's go back to the game, and up here we can put our header, importing it from our components, and pass all the properties that we need. In this case, we need a children and is post. Someone says is post. We also need a function to pause the game. So I'm going to create this function super easily here. We are just basically setting the is pause variable to be whatever it was, but the opposite. Now we can pass here pause game equal to pause game. And as well, we're going to have a reload game. We need to create this function, of course. And this function is going to be super easy. We are just going to update every variable to have the first initial state. So let's put that in here, reload game. And that's all we need in the header. Now, we are getting this error because we are not closing this header. And now we are closing it. And we're getting an error because header is expecting a text. I mean, well, not a text, but a children. Now, if I import this text from React Native, let me go on top and right here, text, hit save. This is going to fix pretty much everything because we are showing the children. And this children is going to have the score. At this point, we have 20 and everything should be working now. Now, let me add some style to this score. And for now, I'm just going to say style equal to, and I'm going to paste this style, which basically we can abstract in here, but I'm feeling a little lazy because this video is taking a little longer than I expected. So if I reload the game now, you can see that every time we eat an apple, we are just growing and increasing the points. Now, if we try to pause the game, we are going to hit this line because we are just going to move the snake if the game is not paused. Now, if I play again and pause, we are moving and stopping. So it's working pretty nice. We can reload the game. The function reload the game, basically it's setting everything to whatever we had already. And that's pretty much all I wanted to show you guys. As you can see, this is a pretty fun game and you can improve it, make it your own. You can create an online version. You can play with another person. And if you do that, make sure you invite me to play with you. And yeah, that's all I have for today. I hope you like this video. I hope you learned something new. I hope you subscribe, you leave me a comment down below. And that's it, guys. I'll see you in the next one. Thank you. Bye.